So this is lesson A2U2L4, systems of equations. So let's talk about it. What is a system of equations? Well, it's when you have two or more linear equations. All right, if you have a linear equation, say 2x plus 3y equals 7, you know that this equation has multiple solutions. You can graph a line and that gives you all the solutions of these two, but x depends on y depends on x, so there's an infinite number of solutions. Now, what if you have two equations with an infinite number of solutions and you want to find the solution that works in both of them? That is a system of equations. Now, when you solve a system, you can get one of three things. The first type is when you graph your first line. Here's the line. Then when you graph the other line, the point of intersection, that is the one solution. So that's your first type. When they go two different directions, you get a point, so you have one intersection. All right, let's say you graph one line and then you graph your next line, and that line is parallel. They will never intersect. They have the same slope but different y-intercepts. Well, here what you have is a no solution because there is no point where these two will intersect. Then the last type that you have, if you graph your first line and then you graph your next line and it graphs right on top of that line, what you have there is infinite solutions. All of the things that make the first line true make the second line true as well. So we just call that infinite solutions. So there's your definition. Here's your three different types. Let's get into some problems. So let's look at problem number 1. We have y is equal to negative 5/3 x minus 6 and y is equal to 1/6 x plus 5. Both of them have an x and y. So we want to know what is the one pair of numbers that makes both of these true. And we're going to solve this with the graphing method. So how do you graph a line? Well, you can make an xy chart, or you can convert it to y is equal to mx plus b form and then use your y-intercept and your slope. Since these are in that form, that's what we're going to do. Now our first line here is the y-intercept is at negative 6. So I'm going to come over here to my y-axis and I'm going to go down 1, 2, 3, 4, 5, 6. Then I'm going to use my slope, which is negative 5/3. Now remember, if you have a negative slope, you can either make the top number negative or the bottom number negative when you get ready to rise run. So for this one, actually, because if I rise negative 5, I'm going to go down, and I'm already so far down on my graph. So let's use positive 5, negative 3. We're going to go up 5, 1, 2, 3, 4, 5, and then we're going to run negative 3. So we're going to go backwards, 1, 2, 3. All right, and here comes our line. So we can get those 2 points and connect them. All right, now let's graph our other one. This one has a y-intercept of positive 5, so we're going to go up 1, 2, 3, 4, 5. Now our slope is 1/6, so we're going to go up 1 and run 6. Okay, so let's connect these two right here. Now, this point where they intersect, that is the solution to our problem. So we're going to have to find the coordinate pair. So from the origin, how do you get here? Well, first, you go over your x coordinate, 1, 2, 3, 4, 5, 6. That's negative 6. And then you go up for your y coordinate, 1, 2, 3, 4. So the coordinate pair that makes both of these true is negative 6, 4. All right, here is number 2. You've got y is equal to 5 and y is equal to 2x plus 7. All right, how do you graph y is equal to 5? That is going to be a horizontal line that intersects the y-axis at positive 5. So all you have to do is go up here, and I'll just use a ruler to keep things nice and neat. Okay, this is the line, y is equal to 5. All right, now let's graph this one. We have a y-intercept at 7, so that's going to be here. All right, when you have a whole number for a slope, but you need to do rise, run, put it over 1. So now from my y-intercept, I'm going to go up 2 over 1. All right, and then we can connect these two. Draw the line. All right, and here is our point of intersection. So what is the coordinate for this? Well, the x is -1 because you go to the left 1, and then you go up 1, 2, 3, 4, 5. There you go. Okay, let's look at number 3. Now, these are not in y-intercept form, so you can either make an XY chart and graph it, or you can convert to slope-intercept form. So let's do it slope-intercept way. We are going to subtract 6x from both sides here. So I have -5y is equal to -6x minus 45. And then we're going to divide all the way through by -5. So I'm going to have y is equal to negative over negative is positive, x, and then negative over negative also is positive. Okay, so let's graph this. Our y-intercept is at +9. So I'm going to come over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's that point. And then my slope is 6 over 5. Now if I try to rise 6 and run 5, I'm going to be all off my graph. So I'm going to do a little manipulation here. Instead of +6/5, I'm going to use -6 over -5. You see they're equal, and you're just going to get the other part of the graph. If I graph +6, 5, that's going to be all up here. If I graph negative, I'm going to get the part of the graph that's here where I can deal with it. So let's rise -6, 1, 2, 3, 4, 5, 6, and then run -5, 1, 2, 3, 4, 5. Then we are going to connect those two lines. Just like this. All right. Now we need to graph this other one, so let me get rid of some of this so we'll have some room. All right, once again, we're just going to convert to slope-intercept form. So I'm going to subtract 2x from each side. That's going to give me 2y is equal to -2x minus 4. Then I'm going to divide all the way through by 2. So now I have y is equal to -1x, or you can just put -x minus 2. All right, my y-intercept is at -2, so I'm going to come and count down 2. There's my y-intercept. My slope is -1, which means -1 over +1. So I'm going to go rise -1, which means go down, and run +1. All right, so there's my point, and then I'm going to connect, go all the way up. All right, so there's my ordered pair. Let me get my coordinates for that. From the origin, my x-coordinate is 1, 2, 3, 4, 5. So that's -5. And I went up 1, 2, 3. Okay, and you can plug them in and check. They should both give you the correct answer. Okay, so here's number 4. Let's graph both of these. Now this one's already in y is equal to mx plus b format. So let's go ahead and graph it, and then we'll convert and graph this one. Now if your y-intercept is at -5, you're coming down 5 on the y-axis. 1, 2, 3, 4, 5. All right, we have a negative slope, so that means I can use -1 +2 or +1 -2. But we'll go -1 rise and then 2 run. So here is our first line. Okay, now let's convert this one. We're going to subtract 3x from each side. So that's going to give me 6y is equal to -3x minus 12. I'm going to divide all the way through by 6. and this is going to give me y is equal to negative 1/2 x minus 2. Okay, now do you notice something about your two equations? They have the same slope. So let's see what that's going to do on a graph. This one, my y-intercept is at negative 2. So there's my y-intercept, and once again, my slope, I can do negative 1 over 2. So that's going to be negative 1 rise and 2 over. Now, do you see what happened? When I graph these two lines are parallel, okay? Parallel lines have the same slope, so you knew that was going to happen. Now, what you have here is a no solution. There is no point of intersection. There is no pair of numbers that will make both of these equations true. Okay, here's number 5. Neither one is in, perfect slope-intercept form, so let's manipulate both of them. This one, I have the y over here, but it has a coefficient, so I'm just going to divide all the way through by 2, and that gives me y is equal to 4x plus 9. So let's graph that. My y-intercept is at 9, so I'm going to come here and go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, my slope is 4 over 1, and once again, if I start trying to go up 4, that's going to put me off of my graph. So what I'm going to do is make it negative 4 over negative 1. So I'm going to go down 4 and back 1. And let's get a graph on this, just like that. All right, now here, to get it in y is equal to mx plus b format, first I'm going to subtract 24 from each side. Now I have 4y is equal to x minus 24, and then I'm going to divide all the way through by 4. So y is equal to, and remember, if you have x over a number, that converts to 1/4 x, so you'll have a slope. And 24 divided by 4 is 6. All right, let's go to the y-intercept at negative 6. 1, 2, 3, 4, 5, 6. And then our rise run of 4. So up 1, 1, 2, 3, 4. Okay, now what's going to happen here is when I draw this line, you're thinking, oh, those lines don't intersect. But actually, you can always continue a line out from its 2 points. And I didn't really get that as straight as possible. So let me see if I can realign that. There we go. That's a better line anyway. The first one was off. So there is your point of intersection. And from the origin, I went to the left 1, 2, 3, 4. So that's negative 4. And then I went down 1, 2, 3, 4, 5, 6, 7. Okay? There you go. Let's do one more. Here's number 6 is our last graphing problem. So first, let's get all these in y is equal to mx plus b form. All right, this one, the only thing wrong is the y has a negative in front of it. So I'm just going to multiply all the way through by negative 1. Some people like to divide by negative 1. Either way is fine. And that's going to change this to y is equal to x plus 6. Now, if there's no coefficient, it's understood to be 1, so you have a 1 over 1. So let's go to y at positive 6, 1, 2, 3, 4, 5, 6. And then a 1 to 1 is just going to give us a line right there. Okay? Now, let's convert this one. Since I want my y over here, what I'm going to do on this one is just reflect the whole equation first off. Then I'm going to divide all the way through by 3, so I get y is equal to x plus 6. What do you notice there? Those two equations match. So when I graph this, what I'm going to get is that line on top of the line that I already have. So what's your answer here? Infinite solutions. Now, let's look at another method of solving simultaneous equations or systems of equations so that you don't have to graph them all the time.